In question 4, we're looking at a series of probabilities of different customer bookings at Harry's Hotel. And we've got a slightly unusual Venn diagram to represent this all happening. So we've got R as the event that a customer books a room at the hotel, which is this one here. We've got B as the event that a customer books breakfast, and D as the event that a customer books dinner. And we're asked in question A to write down the probability that a customer books breakfast but does not book a room. So write down means it should be fairly straightforward. So what we can see is that if they book breakfast, then everyone that books breakfast is a subset of R. So everyone who books breakfast is within the set R, which is that they have a room. So what that is saying is that everyone that has breakfast has a room. So the probability that someone has breakfast but does not have a room will therefore be equal to 0. In part B, we're told that events B and D are independent, and we're asked to find the value of T and hence find the value of U. Now, if two events are independent, B and D here, the probability of B and D occurring is going to be the same as the probability of B occurring multiplied by the probability of D occurring. Now, essentially, if you think about the conditional probability formula, so here we would have had P, the probability given D. If we wanted to work that out, it'd be the probability of B and D all over the probability of D happening. Now, the thing is, if they're independent, it doesn't matter whether or not D has happened. The probability of B happening will still be the same. So we could then rearrange this, bringing this up here, and we would have the probability of B, because it's independent, multiplied by the probability of D is going to be equal to the probability of B and D, which is what we've got down here. So how do we interpret this from the diagram? Well, the probability of B and D occurring is going to be found from the intersection between B and D. So from the Venn diagram, we can see that that is going to be this region here, 0.27. So now all we've got to do is find the product of B and D and see what that gives us. So the probability of B happening is going to be this, which is going to be 0.6, and we need to multiply that by the probability of D happening, which is going to be 0.27 plus 0.15, which is going to give you 0.42 plus T. So we can see we've got 0.27 is equal to this expression here. So if we expand and multiply out, we can see that T is going to equal 0.03. We're then told to use our answer to T of 0.03 to find U. Now, we need to recognise here that there is nothing outside of these two sets. Therefore, all these probabilities must add up together. So in here, that's going to be 0.6 plus U plus 0.15 here plus 0.03 must equal to 1. So all we need to do to find U is just to solve for that, which is going to give us a value for U of 0.22. In part D, we are looking at conditional probability, we can tell from the sign here. This can be quite intimidating, and indeed you can use the conditional probability formula to try and work this out. However, with Venn diagrams, sometimes it's kind of easier just to interpret it from the diagram. So if we look at the first one, the conditional probability tells us what has happened. So for instance here, we're looking at R and B. So here we're looking at people who have booked a room and having breakfast. And within that kind of subset, we're then looking at the probability that they have dinner. And this is, in effect, going to affect the denominator. So let's start off by identifying this region here. So the group which is staying the night and having breakfast. So that's going to be this group here. So that in effect is going to become the denominator, because that's now our total population. So that's going to be 0.6. Within this population, we are interested to find out the probability that people have dinner. So within this, we know that there are going to be 0.27. That's the probability that those people have dinner as well. So the probability that the person has dinner given that they have booked a room and are having breakfast is going to be 0.27 divided by 0.6, which is going to give us an answer of 0.45. Similarly, in part 2 here, the easiest way to try and solve this is by interpreting the Venn diagram. So here, start off with our kind of new subset. So our subset here is R intersection not B. Now this one is quite tricky. In context, this means the probability that they stay overnight, so they have a room, but they don't have breakfast. So that is going to be this group here. So they are within the room set, but outside the breakfast set. But you can see there's actually another set over here when we've worked out earlier in the question the value of U. So the total size of the group in terms of probability who have a room but don't have breakfast is going to be these two combined. So this is going to be our denominator, which is going to be 0.37. And then we want to try and work out from within that subset the probability that they have dinner. So only this group here are also within the dinner set, so it's going to be 0.15 over 0.37, which we can just leave as 15 over 37. In the final part of this question, we are given some additional information about a coach load of 77 customers who arrive at the hotel. Of these, we've got 40 who have booked a room and breakfast, and 37 who have booked a room without breakfast. And we're asked to estimate how many will book dinner. Now, at first glance, this looks pretty tricky. However, we need to just try and contextualize it within the question. So if we put this information here in set notation, it might help. So 40 people have booked a room and breakfast. So using set notation, that's going to be a room and breakfast. And we can see that in the previous question over here, we had worked out the probability that they had at dinner given that they were staying overnight and having breakfast was 0.45. And similarly here, 37 people have booked a room without breakfast. Now that would be R intersection not B. And again over here, we've worked out the probability that someone has dinner given that they're staying in a room without breakfast. So essentially now we could use expected values to work this out. So in effect, we know that this percentage of these 40 people will have dinner, and we know that this percentage of these 37 people will have dinner. So the calculation will be 0.45 times 40 plus 15 over 37 times 37. So if we work that all out, we should get an answer of 33.